All right. So we are going to start Unit 7. Unit 7 will take us tentatively kind of mapped out all the way to the end because in February we've got an in-service day on a Friday this year. So I'm tentatively looking at either the Thursday before the in-service day or the Monday after the in-service day. One of the two. I'm kind of leaning towards the Monday after the in-service day because I'm not going to be here the Monday after the in-service day. So it's an easy Sunday for me to plan. So and frankly, sorry, Blondie, it's all about me. It's not about you. I know, I'm the meanest. Right? So, we know of 3 ways to graph a line. Okay? I'm going to test your memory because today what we're going to be doing is we're going to be solving equations, solving systems of equations. Okay? And the first method we're going to do is using graphing. So let's think back. What are 3 different ways, 3 different methods, if you will, to graph a line? Shout one out when you think you got it.
Linear equation.
They are all linear equations because they're all lines. Yes. But how can I graph them? You've done them before. You've done them for 4 years. Y equals mx plus b is probably the method that you will go to the most. How do I graph a line using y equals mx plus b? So b is the what? Y-intercept, yep, okay. And so we plot the y-intercept, and then what? How do I use the slope? It's the m of the mx, yep. The coefficient on the x, but how on the graph do I use the slope, Maddie? Rise over run. Yep. From that y-intercept point. And then I plot a couple more points and I draw my line in, right? Nice and straight. Now, it's going to be extremely important for you later on when we get into this graphing and stuff that you actually use something straight. A ruler, bend over your piece of paper, an IED, something like that, because you're going to need to be exact today. Okay? So that's one way. That's probably the way that you're going to use the most. It for sure is the way that I use the most. So that's why it's number 1. Anybody know a different way to plot a line? We can do a T-chart. Yep. T-chart is the 3P method. You're going to pick some random x values. You're going to plug those in to your equation to find your corresponding y values, and then you're going to plot your points. Okay? The third one, I expected you two to get those two. Okay? The third one is the least used of the method, so I'm not full on expecting you to get yet. You can always graph a line using its intercepts. you plug in 0 for x, you get the y-intercept. If you plug in 0 for y, you get the x intercept. And since you need 2 points to make a line, there's your 2 points. Okay? So that's just a quick little recap on that. Now what we're going to be doing today is we are going to be using a linear system. So we're going to have multiple lines on one graph. And when we have lines on one graph, there's only 3 potential outcomes that we can have. Okay? So if you think if your one arm is a line and your other arm is your other line, there's only 3 different outcomes that you can have with your 2 arms. Okay? What are they? They could be parallel, right? Okay? So that's one outcome. What's another outcome? Not so much perpendicular. Yes, they can be perpendicular, but they just perpendicular lines do what? They cross over each other, right? So they just intersect. So they can not intersect if they're parallel. They can intersect once, or can 2 lines intersect twice? All lines are straight. Straight, straight, up. Intersect. No. Yeah. Can they intersect 3 times? Oh. Can they intersect 4 times? No. Okay. So it's 0, right? Parallel lines never intersect. 1, or what's the third one? Okay. A what? Nope, that would be intersecting once. Or they what? They overlap, so they intersect infinite amount of times, right? Yep. Okay. So it's either 0, 1, or infinite. Okay. How that looks, oops, my dot didn't, for some reason my dot didn't. Okay. So you can have exactly one solution, and that's what we're looking for. This intersection point would be the solution to the system. So if the lines cross, either perpendicular, somebody over there said perpendicular for parallel when we were doing parallel lines. Okay? So that intersection point would be the solution to our system. So we can have exactly one. We can have no solutions if the lines are parallel. Or we can have infinite solutions. Let me move this up here, and then that way we can get them all in one. If the lines overlap or they end up being the same line, then there's infinite solutions. So throughout this chapter, when we are determining or finding a solution, your answer is going to be one of those three things. Okay? We have many methods. Okay? Off the top of my head, I know of 5 methods to solve a system of equations. We're going to deal with 4 of them in this chapter. Today we're going to deal with graphing. So you should have also grabbed a piece of graph paper today when you came in and grabbed the homework. Okay? So a system of equations, or a system of linear equations, multiple different ways of saying the exact same thing, is just that. It's multiple equations, and we want to find the solution, where they intersect. So, very easy steps for graphing. First step is you got to graph the 2 lines on the same graph. And then step number 2 is where they cross, that's where it is. And then step 3, I will always put in a step 3. Step 3 is check your work. Because you can plug in the solution into all of your equations, all of your original equations, and you'll know 30 seconds after you're done with the problem whether or not you're right. Okay? All of the formatives and all of the quizzes and all of the tests from this unit should be at or near 100% because you are going to check all your work at all times. Okay? So, let's start. We'll do the blue line first. 3x minus 4y equals 8. Okay? How do we want to graph that one? We've got 3 methods. We had y equals mx plus b, we had t-chart, and we had intercepts. Intercepts? Okay? The downfall with intercepts is if I find the y-intercept, I plug in 0 for x, right? Okay? Which is doable. Okay? Plug in 0 for x, I get y, negative 4y equals 8, y equals negative 2. Okay? But then I got to plug in 0 for y to find the y-intercept, or to find the x-intercept. And I get 3x equals 8. Right? Which gives me a fraction. Now, I earlier had said that we need to be exact. So let's not go with that method because we're gonna have to guess as to where that one is. Okay? That third method, the intercept method, only works some of the time. Okay? So instead, how about we go y equals mx plus b? So if I solve this equation for y, I would first off subtract 3x. Then I would divide every term by negative 4. And that's going to give me y equals positive 3/4 x minus 2. Down 2, put a dot, that's my y-intercept. Slope of 3/4 would be up 3, 1, 2, and 3, right 4, 1, 2, 3, and 4. 1, 2, 3, 1, 2, 3, 4. Or I could go down 3, and up 4. Now it's going to be important for you to go all the way across your graph, especially on the first line. because you don't know where those two lines are going to intersect. So you should be going all the way across your graph on the first one. Then you rinse, lather, and repeat for the second one. Here now I would subtract 3x again. That gives me 4y equals negative 3x plus 16. Now I would divide every term by 4. That gives me y equals negative 3/4 x plus 4. From the origin, go up 4, put a dot. From that dot, go down 3, right 4. Down 3, right 4. Up 3, left 4. Also works. Where they intersect, that is our solution. So I see our solution being at this point right there. That point would be 1, 2, 3, 4, comma 1. Quick check. 3 times 4 is 12. 4 times, whoops, got the brakes, what happened there? 4 times 1 is 4. 12 minus 4 is 8. It checks in the blue line. 12 plus 4 is 16. It checks out in the green line. So the graph and the solution of what the actual point is would be my answer. Not one or the other, both. Have to have the graph, have to have the actual point of intersection. Questions, comments, concerns, clarifications? Okay. With that being said, then you try number 2. End up being the same line, okay, which they have the same y equals mx plus b equations on that. So then that would end up being my solution would be infinite solutions. Agree? Try that one. two parallel lines, and we could have seen that right from the y equals mx plus b's, because they both had 1s for their slopes. They had differing y-intercepts. So they were parallel lines, so that is a no solution case. Okay. One more. I think. Yep, one more. Go for it. And then
If she was 3, I don't know.
appear to cross right there, which would be at the point 0, 3. They both have y-intercepts of 3, 0, 3. Plugging it back in, plug in 0 for x, we get 4 times 0 is 0. 0 plus 3 is 3, and 3 is equal to 3. Yes. 0 times 10 is 0. Negative 5 times 3 is negative 15. 0 minus 15 is negative 15. Negative 15 is equal to negative 15. Done. Okay. On this week's homework, pay attention to how the problem is written. Okay? Some of them are inequalities on the graphs. That's Wednesday's work, is graphing inequalities, systems of inequalities. Some of them are equalities. That you can do today on the graph. There should be 2 graphs. I think it's number 2 and number 3. You can do 2 and 3 right now. Okay? I mean, you should know how to do the entire packet, but right now, of stuff that I've taught, 2 and 3.